Good afternoon. We'll start a bit now. So, check lang Danay. Can you hear me and can see my presentation? Am I clear? Nakita niyo akong presentation? Let's wait for about 5 minutes now before we start. Let's wait for others. Hmm. Okay, so let's start. So for our discussion for today, no, so we will be dealing with direct circuits or direct current circuits, no. So here we will analyze some simple electric circuits which contains battery. Okay, so mga battery, the resistors, and capacitors, no, in the next topic bagid. Okay, so after pre-final siguro, which is the combination of resistors and capacitor circuits. Yan. So some circuits contain resistors that can be combined using some simple rules, no, which is ginatawag nato nga Kirchhoff's rules. Okay, so the analysis of more complicated circuits is simplified using the KVL and the KCL, no? or what we or which we call Kirchhoff's rules, which follow which follow from the laws of conservation of energy and conservation of electric charge for isolated systems. So most of the circuits analyzed in our discussion are assumed to be in a steady state. So when you say steady state, it means that the current in the circuit are constant. Okay, so it is constant sila in magnitude and direction. Okay, so a current that is constant in direction is what we call the direct current or DC. So we will study that one, but first we will discuss what is electromotive force. Okay, so we will generally use a battery as a source of an energy. Okay, so as a source of energy for circuits in our discussion, because the potential difference at the battery terminals is constant in particular circuit. So the current in the circuit is constant in magnitude and direction. So therefore, this is what we call the direct current. So a battery is called either a source of electromotive force or more commonly as source of EMF. So the phrase electromotive force is an unfortunate historical term, no, describing not a force mismo, but rather a potential difference in voltage or in volts. So the EMF, may symbol kita sang EMF which is the epsilon. Okay, later on we will use that in a formula. So the EMF of a battery is the maximum possible voltage the battery can provide between its terminals. So we have two terminals, diba? The negative terminal and the positive terminal. So you can think of a source of EMF as a charge pump. Okay? So meaning, when an electric potential difference exists between 2 points, between its terminals, no? So the source moves charges uphill from lower potential to the higher potential. So meaning from negative to positive siya. So we shall generally assume the connecting wires in a circuit which have no resistance. So the positive terminal of a battery is at a higher potential than the negative terminal. Okay, so titingnan natin. Okay, so because a real battery is made of matter, di ba? So it composed of chemicals, di ba? So it's either a lithium ion battery, it's either a lead acid battery. So it's made of matter. So therefore, there is a resistance to the flow of charge within the battery. Okay, so the resistance nga ara dara sa battery is what we call the internal resistance. Okay? So may ara kita ginatawag nga internal resistance, so that is the resistance in a battery. So for an idealized battery with zero internal resistance, so the potential difference across that battery, or what we call the terminal voltage, equals to its EMF, or equal siya sa iya nga electromotive force. So sa real battery naman niya, so this is for a real battery, however, the terminal voltage is not equal to the EMF for a battery in a circuit. in which there is a current sa iyang circuit. Okay? So, para ma-understand ka ni, okay, so for us to understand, so let's have a diagram. Okay, so let's have a circuit. So, meron tayong tingnan natin lang. So, let's say we have a simple circuit. Uh, bakit hindi yan? Ayan. So, let's say we have a simple circuit. Then we have a resistor here. And we have a battery. So, this is the negative terminal, which is the gamay siya nga ano. Then we have a positive terminal, the longer leg. And then inside this battery, so meron siyang small resistance, or this is what we call the internal resistance of a battery dito. So this is our load. Ito yung load natin, which has a certain resistance. And we have this, meron tayong distinct points dito. Okay, so let's say this is point A, or let's say this is point A, this is point B. So from point A to point B, we have a terminal. So this is our battery, positive terminal dito. And then, let's say we have another point, no? Which is, in this case, so medyo wait. Ano natin erase muna natin. Medyo malapit siya. Ayan. So, meron tayong another point dito. So, let's say point C. So, this is for the internal resistance of a battery. Then, we have the point D here. So, yung full circuit natin for the battery is nandito sa loob ng dash line. Ayan. So, meaning, ideally, di ba? Atong hambal atong kagina, for an ideal battery, wala siyang internal resistance. Okay? Wala tayong internal resistance for ideal battery. But for real battery, ito na yung ginagamit natin realistically. Meron talaga siyang internal resistance. Okay? So, we have now this circuit. No? So, we model the battery. Ito yung battery natin. Ayan. And then, yung nasa loob ng dash, dito, sa circuit na to. So let's say, ito yung point E natin and point F. So yung circuit natin is running clockwise. So yung current natin is pamunta dito. So we have a current here. Okay, so yung direction natin is clockwise. So pag ganyan yung direction ng current natin. Yung circuit. Kasi from negative to positive naman talaga, di ba? From low potential to higher potential tayo. So meron tayong naka-dash rectangle dito sa loob ng circuit. So ito yung ano natin ito yung ideal battery natin. Okay, so this is containing an ideal resistance free. Okay, wala tayong resistance diyan. Resistance free EMF in series with an internal resistance R. So ito yung internal resistance natin. So ideally, ito yung circuit natin. Diba? Ideally, ito yung buong circuit natin. Wala siyang internal resistance. But realistically, yung battery mismo is merong internal resistance. Ito. Okay? So, a resistor of resistance R, ito yung load natin, connected siya sa terminals. Okay? So wala namang polarity yung resistor. So it's either, pwedeng pagbalik ta rin yung resistor natin dyan. Yung load natin. So it is connected across the terminals of the battery. So we have point F connected sa point A ng battery and point E connected sa point B ng battery. Okay? So imagine natin na from the battery, no, moving from point A to point D. Okay? And then measure natin yung electric potential nila. Okay? So meaning i-check natin yung potential ng circuit na to sa magkabilang load. So dito rin sa load. So habang while we're moving, no, from point A to point D, okay, so we move through the resistance R. So this is our internal resistance. So however, yung potential difference na natin ngayon, so let's say this is 12 volts, di ba? So normally, hindi talaga to 12 volts. Okay? Kasi meron tayong internal resistance sa loob. But ideally, 12 volts lang talaga siya. Wala siyang resistance. So magkaiba yung ideal tsaka sa realistic na battery. Okay? So nadi-decrease tayo dito ng potential dito. So when we across this one, the internal resistance R, so meron tayong potential difference. Okay? Which is the amount of your electromotive force. So as we move through the resistance R, ayan. So yung ano natin, yung potential difference na natin papunta dito, kasi may current tayo, di ba? So yung voltage now that runs through this circuit is equivalent to, so this is your delta V. So this is your difference, no, in voltage. So that is equal to your electromotive force, epsilon, minus D. Kasi yung EMF mo is 12 volts di ba? Ideally. Ito yung ano mo, ito yung EMF mo, 12 volts ideally. But outside na sa circuit, since meron tayong specific current and an internal resistance of your battery, sasubtract natin. Okay? So that is minus the product of your current and your internal resistance. Okay? So this is now your terminal voltage of the battery. So ito na yung mismong voltage sa labas ng circuit. Ideally, meron tayong 12 volts, but realistically, hindi talaga siya 12 volts because of internal resistance. Okay, so from this expression, from this formula, no, so take note. So notice that the electromotive force here is just equivalent to an open circuit voltage. So that is the terminal voltage when the current is 0. So kung 0 yung current natin, di ba? So therefore, yung voltage natin dito is just your EMF. Di ba? Kung 0 yung current, so multiply mo siya sa internal resistance, so obviously 0. So yung voltage mo is just equal to your electromotive force. Okay, so the EMF is the voltage labeled on the battery. So let's say 12 volts, no? So therefore, yung EMF mo is 12 volts man. Okay? So example na siya. But the actual potential difference between a battery's terminal depends on the current. So depende man siya gihapon sa current naton. in the battery. So we know that voltage is equal to the product of current and resistance. Diba? So voltage is equals to current times the resistance. Okay, so this is just a representation. No? So paano natin siya ma-describe in terms of graphical? So the as long as sa circuit meron tayong madaanan na resistance or resistor. So obviously, yung voltage natin will drop. Okay? So automatically it will drop. So kung titingnan natin dito no sa circuit natin, so it also shows that the terminal voltage yung yung formula natin, okay, must equal to the potential difference across its external resistance. So meron pa tayong external resistance dito na R. So ito na yung sa load mo. Okay? Ito na yung load mo. Hindi load na sa cellphone load yung mismong load like for example, an LED light, di ba? And so on. So may resistance din yan. Or a certain wire. So yung copper wire natin may resistance din yan. Okay? So yung R dito, ito yung tinatawag nating load resistance. Okay? So tinatawag natin siyang external resistance pero tinatawag siya mostly load resistance. So yung load resistor, it might be a simple resistive circuit element. Okay, so parang simple lang siya. Ano ganing purpose ng resistor? Resist the current, di ba? Yun lang yung pinaka-basic na definition. Resist the current. Di ba? From the word itself. Okay, so it could be this load resistor, load resistance might be your LED light, it might be your light bulb, and so on, no? Which is connected to the battery. But we're dealing with DC circuits or direct circuits or direct current circuits. Okay? So basically we have the polarity, the positive and negative terminal. So later on na nakita sa AC, no, sa alternating current. So here, the potential difference across the load resistance is equal to the change in potential difference multiplied by, or the change in potential difference is equal to the current in a circuit multiplied by the resistance or the load resistance mismo. Okay, so we have two formulas for the voltage. Ayan. So basically ito na yan. Ito tsaka ito. So take note of that two equations. So you will use that later on. No? We will use that sa So how about the current here? So for the current, we can just transpose the formula. Okay, so we can just transpose the formula. But wait, no? So meron pa pala tayong load resistance dito. So meaning kasama yung internal resistance tsaka external resistance. So this is now your total electromotive force. Okay? So your EMF therefore is just equal to the product of your external load and your current plus the product of internal resistance times the current. Okay, so this is your another equation. Okay, so this is combining, if we combine these two equations, Okay. So your EMF or your EMF is just equal to the sum of your internal resistance multiplied by the current in a circuit and your external resistance multiplied by your current. So this is your, let's say, ito na yung combination ng formula mo. If we combine this equation 1 and equation 2. So this is your equation 3. Yan. So ito yung equation 3 mo. So this is your formula for EMF or electromotive force. So this is for real. Dealing with real battery. Okay, kasi meron tayong internal resistance and external resistance. But ideally, we can just use the V is equals to IR. Kasi wala naman tayong internal resistance. Diba? Ideally. So kung i-transpose natin ni siya, let's say if you want to solve for the current, your equation for the current will be equal to transpose na lang siya, di ba? So that would be the ratio of your EMF and the sum of your load resistance and your internal resistance. Ayan. Okay, so this is for your real. Okay, so ano to? Real battery. Okay, but for the ideal battery, ideal circuit, we can just have the I equal to V over R. So this is ideal circuit. Okay, ideal circuit na formula. So given mula din dito sa ideal na formula din, in which wala tayong internal resistance. Ayan. So So kung titingnan natin, so this equation shows that the current in our circuit depends on both resistance sa internal tsaka sa external resistance natin sa battery. Okay? So if yung load resistance natin is much greater than the internal resistance, as in many real world circuits, okay, so we can neglect the internal resistance. So paano natin siya ma-neglect? By multiplying, no? So by multiplying the equation 2, ito, equation 3 I mean. So by multiplying this equation 3 para ma-neglect natin, kasi in real world naman talaga, in dealing with direct circuits, no? Minsan hindi na sinasama yung internal resistance. Hindi na nila consider in real world. So that's why most circuits that we will be dealing with in some examples and even in real world, no. Okay, so hindi mo naman malalaman yung internal resistance ng isang battery. Okay? So let's say yung isang 1.5 volt na ever-ready na battery. So malalaman mo ba yung internal resistance niya? 'Di ba yung naka-indicate lang is yung voltage niya. Okay? Not unless you check the specification of that battery. So malalaman mo talaga ano yung chemical compounds na nandyan, ilan yung internal resistance, and so on. And so if we neglect this one, okay, so we have our equations, no? Okay, so I will just adjust this one. We can have our equation that is equal to, if we multiply, no? I-multiply natin yung eto. multiply natin tong equation na to, equation 3, ito. And equation, ito. So if we multiply these two, we can have a, so cross multiply lang na siya, diba? So we can have IE, or current times the electromotive force. Okay. That is equal to I squared, diba? Current squared times R plus I squared internal resistance R. Okay. So ito, this is also symbolizes as your energy, no? Or power. Okay. So this can also be this can be your power ideally. Okay, which is power is equals to current times the voltage. Okay, ideal. Yeah, so P is equals to IV. Okay, can you guys follow? Sino ba nandito? We have dalawa lang. Okay. So let's have our example. Ito. So meron tayong example dito. A battery has an EMF. Okay, so meron tayong EMF that is 12 volts. Okay? And has an internal resistance. So meron tayong small letter R that is 0.05 ohms. And its terminal are connected to a load resistance of 3 ohms. So meron tayong capital R. Ito yung load resistance natin. So hahanapin natin yung current in the circuit and the terminal voltage of the battery. Okay. So using our formulas here na ginamit, okay, so if we want to take the current, so we can just use the internal, the electromotive force or EMF divided by R plus load resistance plus the internal resistance. So that is 12 divided by 3 plus 0.05, or that is equal to 3.93 ampere. Okay, so therefore the current in a circuit has only 3.93 ampere. Pero ideally, di ba? Ideally, we will neglect this internal resistance. Yung current nito would be just equal to 12 volts over resistance na 3 na R. This is ideal, or that is you have 4 amps ideally. But in real, since meron tayong given na internal resistance ng battery, we only have 3.93. Okay, 3.93 amperes. So kung i-round off mo siya, mostly nasa 4 amps din siya, di ba? Okay? So this is the current in the circuit. So hinahanap din dito is the terminal voltage of the battery. So terminal voltage ng battery, this is nasa labas na. Kasi yung terminal voltage meaning kasama dito yung internal resistance. Okay, so that is 12 volts minus the product of your current, which is 3.93, times the internal resistance of 0.05. So kung sa circuit natin lang tawon, direct pag-iina, so this is yung hinahanap na potensya na terminal voltage is ito. Yung dito na part, tsaka yung dito na part. Kasama dito yung current, kasama dito yung internal resistance, and yung EMF natin na 12 volts. Ayan. So that is yung terminal voltage mo lang is just equal to 11.8 volts. So, hindi talaga siya totally na 12 volts yung battery mo. Kasi meron kang internal resistance sa loob. Okay? So, approximately, you only have 11.8 volts sa imong battery. Okay? So, binawasan na dyan yung internal resistance based sa current. Okay? Now, obviously, the same din siya, no? With the use of the current times the load. So, the same lang din. Okay, so you have 11.8 volts for the terminal voltage of the battery. Then next, calculate the power delivered to the resistor. Okay, so power for the resistor. So this is in terms of the load resistor. So that is current, diba? So titingnan natin dito. So kukunin natin yung power dito sa resistive load. Okay? Power dito sa internal resistance natin. And then, yung total power niya mismo. Okay? So we know that power is just equal to the current times the voltage. Okay? Or that is equal to the I squared. Okay? Current squared multiplied by the load resistor and current squared multiplied by the internal resistor or internal resistance. So if you take a look sa ating solution here, we just squared the current. Yung current natin is 3.93 squared multiplied by the load resistance that is 3 ohms. So the power across, okay, so the power across this resistor or resistance is equal to 46.3 watts. 46.3 watts. And the power across this internal resistance is just equal to 0.772 watts. So therefore, the total power, okay, so yung total power na dineliver ni battery across the circuit natin is just the sum of 2. Okay? So you just use the equation na ito. Ito lang yung equation na ginamit natin. Ito. Okay? So this is your total power na binigay ni battery. That is your I squared times the load resistor plus the I squared times the internal resistor. Or that is 47.1 watts. Ito. 47.1 watts. Okay, so are we clear? May questions, clarifications? Okay, so I have only 2 students out of ilan? Sige. So next, we have the resistors in series. Okay, so I think binigay ko to as assignment to you, no? KVL and KCL, no? So kung paano ba kino-compute yung resistance in series or yung resistors in series and in parallel. So first, we will take a look in a resistors in series. Okay. So when 2 or more resistors are connected together, as they are incandescent light bulbs, okay. Let's say meron tayong incandescent light bulb. Okay. Wait. Ito. So naka-connect siya, di ba? Okay. So they are said to be series combination. So connected siya in series. Ito. So dito naman sa second natin sa letter B. So this circuit diagram is for the light bulbs and a battery. So ito na yung equivalent niya na circuit diagram. Oops. Nitong pictorial representation natin. Okay? So what if you wanted to replace the series combination with a single resistor? So ano yung value? Okay? So yan yung tanong. So in a series connection, if an amount of charge or Q exceeds the resistor R1, so the charge Q must also enter the second resistor. So kung ano yung binato ni R1 dito, yun din yung kukunin ni R2 dito. Okay, kung ano yung binato ni R1, yun din yung kukunin ni R2. So supposedly we have a clockwise direction of the current. Yung current natin is clockwise. Okay? So the charge Q must also enter the second resistance. Otherwise, the charge would accumulate in the wire between the resistors. Dito sa point B na to. So therefore, the same amount of charge passes through both resistors, R1 and R2, in a given time interval. And here, sa atong circuit, the currents are the same in both resistors. Okay, so meaning your resistance, your current here in resistance 1 is just equal to the current in resistance 2. Okay, so your I, your total current is just equal to current in resistance 1, IR sub 1, that is also equal to current in resistance 2 o IR sub 2. Okay? Wherein yung I mo, ito yung mula sa battery. From negative to positive tayo. Pero later on, sa combination of complex circuits na, so it depends pa rin kung paano mo siya i-analyze. So you can do the counterclockwise direction or clockwise direction. Okay? Kasi meron tayong tinatawag na mesh analysis eh. So that is dealing with more complex circuits. Siguro sa circuits 1 yun na mag second year or third year ka mo. Okay? So the potential difference applied across the series combination of our resistors here divides between the resistor. Okay, so kung titingnan natin dito, the voltage drop from A to B. Pag dumaan na dito yung voltage natin, so obviously, babagsak. Yeah. So the voltage drop from A to C as well. So yung voltage natin dito, okay, so yung change of voltage natin, if we have a specific voltage here, is just equal to the change in the voltage sub 1 plus the change in voltage sub 2. Oops, bakit? Kulang. V sub 2. Okay. So meaning, yung total voltage mo dito, so ito yung tinatawag nating voltage across resistor R1. And then dito, voltage across resistor 2. So we have V sub 2. So pag tinotal mo tong dalawang to, it should be equal to the voltage source. Kung ano man yung supplied voltage na sa circuit. Okay? So hindi pwedeng hindi sila magtugma. So once na pag-compute nyo, hindi sila magtugma, so there's something wrong with your computation. Okay? So this also sums up as yung voltage mo here. Ano ganing formula to sa voltage? We have IR. So meaning that this is just your resistance 1 multiplied by current 1 mo. So let's say we have the current 1 and current 2. Pero this is just the same current. So you have your I sub 1 plus your R sub 2 multiplied by your I sub 2. Yan. I sub 2. So ito rin yung change in voltage mo. So this is also your potential difference across the battery. Or no. So ito na yung voltage drop mo, I mean. This is your voltage drop papunta sa load mo. Okay? So yung potential difference across the battery is also applied to the equivalent resistance REQ. So yung equivalent resistance natin is just from the formula of the change in voltage drop natin equal to the current. Ito na sa buong circuit ito Ito. Multiplied by the REQ. Ito. Okay. So meaning, when we have a series, no? Kung naka-series yung resistors natin, we can just sum. I-add lang natin yung resistors na to. And that would be your equivalent resistance in a circuit. So that is the sum of your resistance or R equivalent natin. Then, you could just multiply the current, supplied current dito sa circuit natin. And then you will have your voltage. Okay, so ito na yung voltage mo. When you say voltage drop, okay, when you say voltage drop, ito yung pag-decrease, no? Decrease ng electric potential natin or yung voltage supplied natin across a resistor. Okay, so yun yung tinatawag natin voltage across a resistor. So meron talagang voltage drop yan. Okay. So if you combine now the equations, these equations, diba? So kung i-combine natin siya, you can just have this equation now. Ito lang yung equation mo. Okay. So the equivalent resistance, so let's say if you have 3, 4, 5, 6 resistor, you can use this formula. So you can just have a sum of R sub 1, R sub 2, R sub 3, and so on. So depende kung pila man ang resistance, ang resistor sa mga circuit. Okay? That is for series. Pag series, ina-add lang natin yung resistor and then yan yung equivalent resistance niya. Then you can just use the formula here. Itong formula na to. Yan. Okay, itong formula na to. Questions? So ano yung ano nito? Meron siyang meron siyang disadvantage dito when it comes to series, 'di ba? So let's say napundi to. Let's say napundi to. Napundi siya. So meaning the other bulb will not light. Kasi open circuit na to. 'Di ba? So open na to, hindi na siya closed, open circuit na siya. Kasi ano to napundi na 'Di ba? Nasira na siya. So meaning na dalahig ni siya. Okay, dalahig siya. Yan yung isa sa disadvantage pag nasa series connection. Pero pag nasa parallel, ayan, ito na yung parallel. Okay? So, let's consider these two load resistor. Okay, so we have two light bulbs here. Pag nasira to, ilaw pa rin to. Di ba? Kasi hindi naman siya naka-series eh, naka-parallel siya. So connected pa rin yung circuit niya dito. Okay? Connected pa rin yan. Okay, ito yung advantage ng parallel over series. Okay. So as with the series combination, di ba? So ano naman yung value natin sa resistor dito? Yun ba ay ina-add lang natin? Ano ba? Paano ba natin kukunin yung resistor dito? So the potential difference, no? The voltages across these resistors are just the same. Okay? So kanina, yung current the same. Doon, di ba? Current is the same. Pagdating dito, yung voltage dito across each resistors are the same. Okay? So meaning your change in voltage here is just equal to your voltage across first load. Okay? So let's say ito yung V sub 1 mo and ito yung V sub 2 mo. Or voltage across that resistor. Okay? So this is also the same as in voltage across resistor 2 mo. Okay? So the same lang sila. So when charges reach point in this point, let's say point A, di ba? So pag punta niya dito, pumunta dyan yung current, so may split yung current natin. So we have I sub 2, pamunta dito sa load R sub 2, and meron tayong I sub 1, punta dito sa first resistor natin, first load natin. So ito yung tinatawag nating junction, yung point na to. Okay, so a junction is any such point in a circuit where a current can split. Okay, so this split results in less current in each individual resistor. So parang hinati mo yung full current mo sa dalawa. Okay, so hinati mo siya. And because electric charge is conserved, di ba? So the current here that enters point A must equal to the total current na inilabas niya. Okay? So therefore, your current here should be equal to your current in across resistor 2 plus your current across resistor 1. Okay? Or equivalent to that should be, or equivalent to that would be the formula using the current, that is V over R. Or that is your voltage 2 divided by R2 plus your voltage 1 divided by R1. So this is your current, your total current. Okay? So yung kung ano yung inilabas na current, yun din dapat yung ano. So parang reciprocal siya sa series, di ba? Sa series, we deal with the voltage. Okay? But in parallel, we deal with current. Ayan. So we can now have your voltage, your total voltage, your voltage across resistor, your V sub 2 and V sub 1. So pareho lang siya, di ba? So V is equals to V sub 1 which is equal to V sub 2. Pero paano natin siya masosolve? If there are 3 or more resistors in parallel. So this gives our equation as this one. So this is just the reciprocal of the given value of resistance plus the reciprocal value of your second resistance and so on. Okay? Kung may resistor 3 ka pa da, so reciprocal mo lang siya, 1 over the R3, kung naman na value. And then, yung answer da i-reciprocal mo ulit. Okay? So this expression shows that the inverse of the equivalent resistance of two or more resistors in a parallel combination is just equal to the sum of the inverses of the individual resistances. So furthermore, the equivalent resistance is always less than the smallest resistance in the group. So take note, no? The equivalent resistance is always less than the smallest resistance in the group. Okay? So meaning, for example, yung R1 mo is equal to 3 ohms. 3 ohms. Yung R2 mo is equals to 5 ohms. Therefore, yung equivalent resistance mo, pag nakaparallel yan, should be less than the lowest or the smallest resistance in the group. Okay? So pag yung resistance equivalent mo higher or greater than the smallest, 3 ohms, magtaka ka na. It might be wrong sa imong calculation. Baka may mali. Kasi yung equivalent value dapat dito is less than the smallest resistance. Okay? So take note lang ha. The equivalent resistance is always less than the smallest resistance in a group, in the group. Okay? So, meron tayo dito. Ito. So, this is a combination of series and parallel. So, meron tayong combination of series and parallel. Tingnan natin dito. By the way, ano yung KVL, KCL, no? So, I think you have done that part. Okay, so na-check ko naman yung mga nagbigay ng those who submitted their assignments. Already check your work. Okay, so tingnan natin dito sa series and parallel connections. Ayan. So, saan ba tayo uuna? Ano ba yung uunahin natin na anong uunahin natin? Series ba or magpa-parallel tayo? Actually, it depends, no? It depends on you. You can either start with the parallel or you can start with the series connection. Wala naman pinagkakaiba yan. So, you can just start with series and then parallel and so on para ma-achieve mo yung single circuit na lang. Okay? So, for this example, meron tayong 4 resistors na connected siya. Ito. So, 1, 2, 3, 4. Okay, meron tayong 4 resistors. Yung dalawang pair connected in series, yung dalawang pair naman connected in parallel. Okay? So, titignan muna natin kung saan ba pupunta yung current natin. Saan ba yung pinakasimple? O ano ba yung pinakasimple na gagawin natin dito sa circuit na to? Okay? So, for the series, we can just add the resistor. Diba? Add lang natin to. That is 8 plus 4. Okay? So, you have your 12. And here, nakaparallel siya. So, therefore, we can just get the inverse or the reciprocal of each resistor and then inverse it. Okay? Or that is 1 over 6 plus 1 over 3. Okay? Or that is equal to 3 over 6 ohms then inverse mo siya, or that would be equal to 6/3, or that is 2 ohms. So the sum or the equivalent resistance for this parallel connection is just 2 ohms. So kung titingnan nyo at dito sa letter B na, okay, so meron na tayong dalawang series connection or dalawang resistor na naka-series. Okay? Meron na tayong dalawang resistor na naka-series. And pag naka-series siya, we just add the resistor. The resistance, I mean. Therefore, this circuit, yung total or equivalent resistance niya is just equal to 14 ohms. 14 ohms lang siya. Okay, so 14 ohms lang. So this is what we call the combination of resistors that is in series and in parallel. So ano pa lang to resistance pa lang to. So what if you have a voltage, supplied voltage? What if you have a supplied current? So kukunin mo yung total current sa circuit. Kukunin mo yung voltage across that resistor. Diba? So you can simplify. Yung gagawin mo is simplify the complex circuit using this series and parallel connections. I-simplify mo siya, Danay, and then you can just proceed with your calculations. But in terms of getting the voltage drop across loads or across the resistors, mainly you cannot simplify this one, like this case, no? Kasi what if yung hahanapin ni problem is what is the voltage across this resistor? What is the voltage across this resistor? Diba? So, kukunin mo yan isa-isa. First, you will check the current. Okay? So, you have your current here, current here, current here, and so on. So, in this case, we will be using the KVL and the KCL, or the Kirchhoff's voltage law and the Kirchhoff's current law. Okay, so ito yung pag-solve, no, in how to simplify the circuit using the series and parallel connection in terms of resistors. Okay. Sa capacitor naman niya, baliktad siya, di ba? Magkabaliktad yung series tsaka parallel ng resistor tsaka capacitor. Okay, so if ano niyo siya, if you can recall sa previous topics natin sa resistor, sa capacitor I mean, di ba, magkaiba yung computations nilang dalawa. Ayan, meron pa tayong another example. Ito. So, what if meron tayong value? Okay? What if meron tayong value na voltage? Di ba? So, what is the current in each resistor? O, di ba? So, each resistor. So, ilan yan? So, what is the value? Ano kayo ng value niyan? So, yung equivalent circuit na equivalent natin dito, 'di ba? We have 4 resistors, 'di ba? So, yung R equivalent natin, yung total equivalent natin is just 8 plus 4 plus 2. 'Di ba? Which is 8 plus 4 which is 12. Diba? Kasi yung hinahanap natin is between A and C. So let's say meron tayong voltage source na 42 volts. And then yung kukunin natin is yung voltage, yung current dito, and current nito. Okay? So first, so kinuha na natin yung di ba? Yung total equivalent. So yung total equivalent resistance natin is 14. Diba? So 14. So therefore, we can just solve for the current. Yung current kasi natin should be equal to the, ito yung pag-checking natin current dito. So that is yung voltage across this one. Kaso wala naman tayong kinocompute na voltage, no? Only the current. Okay, so that is the change in voltage across point A to point C, or that is the voltage across this one. So voltage across AC. Na given naman, that is 42 volts over your equivalent resistance, that is 14 ohms. Okay? So therefore, yung current mo is 3 amps. Okay? So you have 3 amps, 3 ampere. Okay? So meaning, ito yung total current mo sa buong circuit sa buong circuit. Pero yung tinatanong kasi, each resistor. Okay? So meaning, babalik ka dito sa, ano mo, dito. Babalik ka dito. So first, kukunin mo muna yung voltage. Okay, so let's take the voltage. Diba? Sabi natin, pag nakaparallel siya, the same lang yung voltage nila dito, diba? So meaning, voltage 1 here is just equal to voltage 2. Or it means that the current here is just also equal to the twice of this current. Kasi ini-split mo yung current dito eh. You have your I1 and I2 now. Diba? So meaning, yung I mo dito, which is 3 amps, I, which is 3 amps, and then you have your I1, which is unknown, and you have your I2, which is unknown din. So yung current mo na 3 amps is just equal to I1 plus I2. Diba? Kasi kung ano yung pinasok mo na current, dapat yun din yung the same as yung total na inilabas mo. So this is just the sum of your current. But take note that yung voltage natin is the same as this one. The same lang sila. Okay? So therefore, your current here sa yung I sub 2 natin dito is just twice as yung current sa I1 natin. Okay, so twice siya. So therefore, your total current or your 3 now should be equal to I1 plus 2. Should be twice of your I1. So yung I2 mo pala is twice of I1. So therefore, you can just have your I1 plus 2 of I1. Ayan. So ito yung I2 mo eh. Twice siya ng I1 mo kasi the same sila. So ang voltage from dito tsaka dito. So the same sila pero notice the value of the resistor, di ba? So ito 6 ohms, ito 3 ohms. So obviously, this is mas mataas yung current dito compared dito. Okay? Now, if we can, for this equation, we can now have the I1. So, transpose lang. Okay, transpose natin. So, divide both sides by, So, obviously, you can have the value, you can now have the value of I1, which is 1 ampere. Ito. And then, solving for the I2, that is the twice of I1, that is 2 amps. Okay? So meaning mas mataas yung current dito. Mas mataas yung current pala dito. Kasi mababa lang yung resistance. So I2 mo, this is 2 ampere. And then dito, yung I1 mo is 1 ampere. Ayan. Okay. So yung current dito sa loob ng circuit na to, sa buo buong circuit kasi yung kinuha na natin ng resistance. Okay, so from point A to point C, kinuha natin yung current. Okay. So buong equivalent resistance natin for the circuit, that is 14 ohms. Then divide natin by dinivide natin sa 14 ohms yung voltage across these resistors, tatlo. Then kinuha natin yung equivalent current niya. Yung supplied current niya is 3 ampere dito sa loob. Pero kinuha natin yung current from point A kasi magiging point A na lang din to eh. Diba? So between point A and point C. So between dito is B, point B. So ano ba yung current dito? So ito yung kinuha natin. Okay? So there you have it. You have now your current in across 6 ohms and current across 3 ohms. Okay? So ito lang yung ino-note nyo. Pag mababa yung resistance, it should be greater current. Okay? Kasi 'di ba nga yung meaning ng o yung definition ng resistance is to resist current. So meaning the higher the resistance, the lower the current. The lower the resistance, the higher the current. So yun pa lang, dun pa lang ma-analyze mo agad yung circuit na dapat yung current dito is mababa. Tapos yung current dito is mataas. Mataas. Okay? So pag hindi tugma, pag nagkabaliktad yan, so therefore there's something wrong with your calculations again. Okay. So questions, clarifications. So kung i-check natin siya, no? Obviously we can check this out by using the total voltage, no, across the circuit. So dapat magiging magiging 42 volts siya. Okay? So that is the voltage across this resistor plus the voltage across these resistors. Yeah. Or that would be the current, okay, 6 times 1, that is 6 volts, plus 3 times 2, no? Ito, 3 times 2 amps, that's 6 volts again. And you have your 12 volts, ay yung 12 ohms mo, ito, 12 ohms times the current, which is 3, diba? So, that is 36 volts. So, kung total mo siya, 36 plus 6 plus 6. So, ito So, yung total voltage dito, yung voltage dito is 12 times current na 3. Diba? So, 12 ohms to times 3. Or this is 36. Then dito, yung voltage mo naman dito is equal to yung current mo na 1 amp multiplied by 6. Or you have your 6 volts here. And dito, you have your 6 volts again. So yung pag tinotal mo to, it should be the same as 42 volts. Ito yung inilabas mo kasi. Okay, so meaning na-conserve yung energy. Okay, so we have a conservation here. So 36 plus 6 plus 6. Tama ba? 42 ba? Tama, di ba? Oh, so ito pala, tama di ba? You have your 6 volts. Okay. So, dito lang pala. So, point A to B and point B to C. So, pag tinotal natin to, yung voltage niya is just the same, di ba? Voltage in a parallel connection is just the same. So, therefore, yung voltage mo across this one is 6 volts. So, tama din. Voltage mo dito is 6 volts din. So, you have your 36 plus 6. You have your 42 volts. Ayan. So, chinek lang natin. Okay. So, muntik na ako dun ah. Kasi 'di ba pag in parallel, yung voltage natin the same lang. Ayan. Okay. So dito, voltage mo dito 6 volts, voltage mo dito 6 volts lang din. So tama. So how about ito? Ito mas ano to? Meron tayong ano, 3 resistors in a parallel. 1, 2, 3. So ano yung equations natin dito? Or paano natin to isosolve? So this is just a simple parallel combination no, of 3 resistors. So tingnan nyo na lang, no? Yung current natin, yung total current natin, in-split natin into 3. Diba? You have I sub 1, I sub 2, and I sub 3 with respect to this value of resistors. So magtatanong ako, okay, diyan pa kayong dalawa. So sa tatlong resistor, saan ba dito yung mas malaking current? Saan ba dito yung mas malaking current? Huwag niyong tingnan to. Huwag niyo muna tingnan to. So obviously, yung mas mataas na current dito is yung pinakamababa, di ba? Ito yung pinakamababa. Then, ito yung pinakamataas na value ng resistance. So obviously, ito rin yung pinakamababang current. Okay? Okay. So now, the problem here asks us to calculate the equivalent resistance of the circuit. So simple lang. Sum up mo lang yung inverse nilang yung tatlo. That is reciprocal of 1 over 3 ohms plus 1 over 6 ohms plus 1 over 9 ohms. Then, reciprocal mo ulit. So, yung total equivalent mo is just 1.64 ohms. Okay. So, pag ginawa mo to as simple circuit, ito yung battery mo. Ganito na lang siya. Ito na yung R equivalent mo. Oops. Ito na yung R equivalent mo. Isa na lang. Okay? Isa na lang siya. So, R equivalent mo is 1.64 ohms. Then, meron tayong follow-up question dito. Find the current in each resistor. So, obviously, you know your formula now, based dito. I is equals to V over R. This is, this is in ideal. Kasi wala naman nakalagay na may internal resistor tayo. Pero what if meron tayong internal resistor dyan? So, different story naman yan. Okay, different story yan. So, we are here with the ideal circuits, no? Na ninineglect natin yung internal resistor, internal resistance ng battery. Okay? So, to find the current in each resistor, you can just use the formula. So, meron tayong 18 volts na battery supplied. And then, i-divide mo yan sa each resistor. So, for the I1, you have 18 divided by 3. So, therefore, you have 6 amps dito sa 3 ohms. Okay? Sa 3 ohms, you have 6 amps. For the 6 ohms, you have 3 amps. And for the 9 ohms, you have 2 amps. So, divide mo lang siya. Okay? Divide mo lang siya. That is 18 divided by 6, 18 divided by 9, and 18 divided by 3. Then, there you have it. Your current. Okay? So, what is the total current? So, total current is just equal to your I1 plus I2 plus I3. Therefore, you have 6, 7, 8, 9, 10, 11. So, total of 11 amps. So, yung current dito is 11 amps. So, what if hindi to? So, to check natin, no, kung tama ba yung 18 volts. So, multiply mo lang to 1.64 sa 11. Tama ba? Check natin, ha. 1.64 times 11. Ayan. 18 volts nga. 18.04 volts. So, meaning tama yung calculations natin. Okay? So, ito kasi, ano to eh, 18 divided by 11. Ayan. So, 1.636363 to. Ayan. So, ito yung current, ito yung resistance, equivalent resistance. Then, pag minultiply mo sa total current, which is 11, obviously, you can get the whole number na 18. Ayan. 18 volts. So, meaning sakto yung calculations natin. Questions? Verifications? Wala? So, next. Ito, yung ano, another follow-up question, no? So, apply the relationship. Okay, so ito yung formula natin. Power is equals to I squared times R. So, current ng resistor, ito yung resistor mo. And then yun yung power across that resistor. Okay? So, this is just for the P sub 1. This is for your first resistor. Ito yung 3 ohms. So, you can just multiply the current, that is 6 amps squared, multiplied by 3 ohms. There you have it. You have now your 108 watts. And so on for the P sub 2 and P sub 3. Then for the total power, just sum up. Okay? So, sum up mo lang siya. And another formula for the power, in case na wala to, you can just have P is equals to IV. Diba? That is your current multiplied by the voltage. Current times the voltage. So, kung titingnan natin, total nito, so total power natin is equal to, kano ba yan? 108 plus 54 plus 36. You have 198 watts. 198 watts. So, ito yung total power mo. So, using this formula, yung total current natin, ilan yung total current natin? We have 11. Oops. We have 11 multiplied by total voltage. Ilan yung voltage natin? 18. 18. So, dapat magtugma to sa 198. So, 11 times 18. Ayan, 198 nga. Okay? So, that's our the ano, yan yung mga formula na pwede nyo gamitin to check your answers. Okay? Ito yung total current and then ito yung total voltage niya. So, therefore, ito yung total power niya. Pag ito, sinum up mo yung each power across the resistor. Okay? So, walang nasasayang, lahat na conserve. Ayan. Okay, so punta tayo sa Kirchhoff's rules. Okay, meron tayong junction rule, saka meron tayong loop rule. So, naano na, no? Ang combinations ng resistors, which can be simplified and analyzed using the equations na change in voltage that is equals to V equals to IR. Diba? Ito yung formula natin ginamit. And the rules for series and parallel combinations of resistors. Yan din. But however, no, it is not possible to reduce a circuit to single loop using these rules. So not all the time na ito lang yung pwedeng gamitin natin. So that's why naka-invent si Kirchhoff ng dalawang principles. No? That is a junction rule. So this is at any junction, the sum of the currents must be equal to 0. Okay? Ito yung tinatawag natin na KCL, Kirchhoff's current law. And loop rule, so the sum of the potential difference across all elements around any closed circuit loop must be 0. Or this is also known as KVL, the Kirchhoff's voltage law. Okay? Sa KCL, summation of current, 0. KVL, summation of voltage, 0. Okay? So, sa mga example ito. So, kung i-apply tayo ng KCL, KVL, di ba? So, yung I1 mo, minus I2, minus I3, should be equal to 0. Yan. Ito kasi simple lang to eh. So, you can just simplify the circuit, then apply the usual formula. The V is equals to IR, the I is equals to V over R. Yan. Yan lang yun. And then, for the power, you have your PIV. Or you can get also the voltage using the P over I. So, transpose lang ng mga formula. Okay, so you have these formulas. Yan. Okay, so sa junction rule tayo. Ito pala. So at any junction, the sum of currents must be equal to 0. So the amount of charge flowing out of the branches on the right must equal the amount flowing into the single branch on the left. So meaning kung ilan yung ipinasok, dapat yun din yung inilabas. Walang bawas, walang kulang. Okay? So meaning, ito yung I1 mo, ito yung total current mo, minus yung inilabas mo, minus ng inilabas mo ulit, dapat yung total niya should be 0. Okay? Kasi nagko-conserve tayo. Dapat walang labis, walang kulang. Ayan. So, for the loop rule naman, so the sum of the potential differences across all elements around any closed circuit loop must be 0. Okay? So, take note that it depends on the what do you call this one? Direction of the current, I mean. Yan. So, meron tayong inaano dito. Ayan. So, charges move from the high potential end of a resistor towards the low potential end. So, if a resistor is traversed in the direction of the current, the potential difference across the resistor is negative man. Okay? So, negative man tayo. So, you can encounter that one, no? Especially if kung ano yung ginamit mong loop, kung counterclockwise ba or clockwise. Okay? So, you can encounter that may encounter ka nga negative value sa imong voltage or current or resistance. Okay? So, take note that if a resistor is traversed in the direction opposite to the current, okay? Opposite to the current, so meaning like this one. So the potential difference across the resistor is positive. Okay? Ayan If a resistor is traversed in the direction opposite to the current, the potential difference is positive. If a source of EMF, assumed to have a zero internal resistance, so ideally, is traversed in the direction of the EMF from negative to positive, di ba? Ito naman talaga yung direction natin for the EMF. From negative to positive tayo. Always yan. So the potential difference is positive. Ito siya. Okay. So if a source of EMF assumed to have zero internal resistance, is traversed in the direction opposite to the EMF. So opposite naman siya from positive to negative. Then obviously, yung potential difference mo or yung electromotive force mo is negative man. Okay? Magne-negative ka dyan. So there are limits, no? There are limits on the numbers of times you can usefully apply Kirchhoff's rules in analyzing a circuit. Okay? So you cannot do it twice. Kasi nag-loop ka ulit, pag nag-loop ka ulit, maiiba yung computations mo. So you can use junction rule as often as you need, as long as you include in it a current that has not been used in a preceding junction rule equation. So in general, the number of times you can use the junction rule is one fewer than the number of junction points in the circuit. So depende kung saang junction point ka sa start mag-evaluate. Okay? Then you can apply the loop rule as often as needed as long as a new circuit element. So new circuit element meaning it might be a resistor or a battery or a new current appears in each new equation. So in general, to solve a particular circuit problem, so the number of independent equations you need to obtain from the two rules equals the number of unknown currents. So titingnan nyo, ilang elements ba yung nandyan? Ilang unknown currents ba yung nandyan? Kasi each element has each current. Diba? And each element has each voltages. Diba? Meron tayong voltage drop na tinatawag. So, complex networks containing many loops and junction generates a great number of independent linear equations and a correspondingly great number of unknowns. So such situations can be handled formally through the use of matrix algebra. Ayan. So plus minus lang kita diri. Plus minus inverse and so on. So kung ano ang gingamit na sa series and parallel and combination of those, you can just still use those equations diri sa Kirchhoff's rules. Okay? Just make sure that the summation of voltages and currents are zero. Okay, so meron tayong example dito. Ayan. Ito, simple circuit lang siya. But take note, meron tayong apat na elemento dito. We have 4 elements here. 2 voltages source and 2 load resistances. Okay? So a single loop circuit contains 2 resistors and 2 batteries as shown in the figure. So neglecting the internal resistance of the batteries, so find the current in the circuit. So using the KCL, kasi current tayo, KCL. So summation of current should be equal to 0. So meaning, kunin muna natin yung current across each resistor. Diba? Which is I is equals to V over R. Okay? So if we have these directions ang current natin, so we have a clockwise direction. So from this point, so from point A tayo. Okay, so from point A tayo. So tingnan nyo, kung titingnan natin, so meron tayong dalawang voltages. Di ba? So the 12-volt battery sa baba, much stronger, no? Compared dito sa 6. So therefore, yung current natin should be counterclockwise. So dapat yung direction ng current natin is pa ganito. Pero yung direction kasi ng current is clockwise siya. So therefore, we expect our guess for the direction of the current to be wrong. So meaning, yung direction ng current natin na clockwise is wrong. Okay? Wrong yung direction. Pero yung final answer, correct pa rin. Okay, so it should be correct, no? So therefore, we expect our guess for the direction of the current to be wrong, but we will continue and see how this incorrect guess is represented by our final answer. So let's categorize first. So we don't need Kirchhoff's rules to analyze this simple circuit, but let's use them, no, anyway, to simply to see how they are applied using this simple circuit. Actually, you can use the simple, no, parallel combination, series parallel combination. But uh, in terms of the KCL, we will apply the this rule, no, this KCL law. Okay, so let's assume that the current is clockwise. Kasi yun naman eh. Yun naman talaga yung nandito sa ano natin, sa figure. So assume lang natin na clockwise siya. So meaning we traverse the circuit in clockwise direction starting from point A dito. And we can see that from A to B, di ba? So it represents a potential difference of positive. Positive yung E sub 1 natin. So we have positive E sub 1 that is from point A to point B. Okay, isa-sound siya ha. And then, what's next? So, from point B to point C, kasi clockwise tayo, from point B to point C, so it represents a potential difference of negative IR. Negative IR. Okay? Bakit negative IR? Di ba? Based lagi na sa ating ano, representation. Pag yung if the charges no move from the higher potential end of a resistor toward the lower end. So if a resistor is traversed in the direction of the current, okay, if the resistor is traversing to the direction of the current, meaning clockwise siya, clockwise din yung resistor natin. Therefore, you can have your negative potential difference. Okay, so you have your negative R here, or this is negative I multiplied by resistance 1. Then what's next? From C to D. Okay? So from C to D, so yung ano natin is dapat from negative to positive, no? But since this is from positive to negative, so therefore this is negative 12 volts. Or you have your negative E sub 2 or epsilon sub 2. Yeah. And then from this case, from point D to point A, so this represents a potential difference of negative. Negative pa rin. Okay? That is negative I times R sub 2. So yung equation nito should be 0. Okay, yung total niya, dapat 0 siya. Okay, so first, titignan natin, no? So solve natin. Okay, so yung total current natin, so we have here the formula now, that is I is equals to the E sub 1 minus E sub 2. This is your potential difference of these two voltages. That is 6 volts minus 12 volts. Diba? Or kung ano to siya, that is 6 minus your I multiplied by your 8 minus 12 minus I. Then, ano ba yung resistance natin? R2, 10 is equals to 0. Yun dapat. Pero wala tayong value ng current. Di ba? Yun yung hinahanap. Find the current in the circuit. So, divide both sides by I. Di ba? So, divide both sides na natin by I. Kasi yung formula natin is, ito dapat voltage divided by resistance. So, this could be simplified by the voltage difference of 2. So, that is 6 volts minus 12 volts. Then, divide mo lang siya. So, 6 volts divided by 8 plus 10. Kasi naka-series naman to eh. Naka-series yan. Or that is equal to negative 6 over 18. So, yung I mo, yung current mo is negative. 0.33 ampere. So, may negative ba na current? Tama ba? Negative 0.33 ba? So, yung negative sign dito, it indicates that the direction of our current is opposite to the assumed direction. So, meaning mali. Wala tayong negative na current. Di ba? Wala tayong negative na current. So, the EMF, yung voltage source natin, yung 6 volts at 12 volts, in the numerator, subtracted because the batteries in our figure have opposite polarities. Di ba? So, hindi siya magkatugma. So, opposite yung polarity niya from this direction, from clockwise direction. So, the resistance in the denominator add because the two are in series. Okay? So, what if the polarity of the 12 volts were reversed? So, paano siya mag-affect sa atong circuit? Let's say, ito magiging positive, ito yung magiging negative terminal. So, if that case, so, kung pa-positive lang din to. Or you will now have your positive 18. So, magiging eraser pa to. Ayan. So, you will now have your 18 over 18 or yung current mo is 1 ampere. If yung polarity ng voltage source mo dito na 12 volts is the same as dito, yung direction niya. Okay? So, meaning negative, positive, tapos negative, positive. That's what I mean. Okay? So, ito yung ano natin. Ito yung equation natin. So, saan dito yung ano? Yung tamang sagot. Ito ba o ito? So, it depends, no? So, ito yung tamang sagot kanina. Pero yung direction ng current natin should be pabaliktad, counterclockwise. Pag nag-counterclockwise tayo, yung current natin dito would be positive 0.33 ampere. Ito yung pag hindi natin ginalaw yung polarity ng yung yung polarity ng voltage hindi natin ginalaw, pero yung direction ng current, ito yung binaliktad natin. Okay, pag binaliktad natin yung direction ng current, magiging positive yan. Okay. So magne-negative lang yung current natin kasi nag-negative siya yung pag-solve natin kasi mali yung direction ng current. Yun lang yung explanation dito. Ayan. So next we have this last circuit. Explain natin, then we will dismiss our class. I have only 25% remaining of my battery. Okay, so let's have this one. So meron tayong isang napaka simple na circuit. Okay. Meron tayong pinakasimple na circuit dito. Wait. Napin ko lang yung kodigo ko. Ayan. Okay, so find the currents I1, I sub 2, I sub 3 in the circuit shown in the figure below. So, figure 28.15. Okay. So if we take a look, no, we have a two voltages again. So we have V sub 1 here and V sub 2 there. So meron tayong ilang loops ba to? Okay, so first, ano yung gagawin natin dito? So mag-imagine muna tayo, no? So imagine physically rearranging the circuits while keeping it electrically the same. So can you rearrange it so that it is consist of simple series or parallel combinations of resistors? Or you should find that you cannot. So obviously, no, hindi natin ito ma-arrange. Kasi yung direction ng current natin, tsaka yung voltage source natin is magkadugtong, no, sa magkaiba-ibang load resistor natin. So we cannot simplify the circuit by the rules associated with combining resistance and combining the resistance in series and parallel. So therefore, this kind of problem, we must use the Kirchhoff's rules. Okay, so we will use the KVL or KCL. Okay, so in this case, we will use the KCL. Okay, kasi yung hinahanap dito is yung current. Okay, current ng tatlong points na to. Okay, so we now have one equation with three anodes. Diba? Sa KCL natin, Kirchhoff's current law, summation of current should be equal to 0. So meron tayong I1, I2, and I3 na anode. So therefore, meron tayong equations na I sub 1 plus I sub 2 plus I sub 3 is equals to 0. Ito na yung first equation natin. Okay? So, and then, there are, ilang loops ba to? Ilang loops to? Tatlong loops to. We have the point A, B, C, D, A. First loop. Second loop. We have B, E, F, C, B. Second loop. And third loop. Yung third loop natin is yung kabuuan. We have A, E, F, D, A. Okay? Tatlong loops tayo. Alright. So, to solve this problem, no, we just only need two loop equations to determine the unknown currents. Kasi hindi naman pwedeng dinaanan mo na tapos dadaanin mo ulit. Diba? Yan yung rule. Dapat once lang. Okay? Once mo lang madaanan. So, I think we can just first loop and second loop. Diba? So, madadaanan natin yung ito tsaka ito. Okay? Pwedeng yan, pwedeng ganyan. Pwede rin yung kabuuan. Alright. So, we'll just use no, the first loop and second loop. Okay, the ABCDA, ABCDA, and the BEFCD. Yan. So, let's choose to traverse these loops in the clockwise direction. The clockwise tayo, and then apply natin yung KCL. Okay, magki-KCL tayo sa first loop, and magki-KCL din tayo sa second loop in a clockwise direction. So, to solve, no, for our equation 1, okay, so ito yung equation 1 natin. So, let's say ito yung equation 1 natin. So, paano ba natin to isosolve, no? So, using the loop ABCDA. Okay, kunin mo natin yung current using ito. Alright. So, meron tayong ABCDA, diba? ABCDA. So, meron tayong 10 volts. So, positive yung pinaglabasan niya. So, we have positive 10 volts. And then, ano ba? Papunta dito eh. We have, ito, 6 ohms times the I sub 1. Negative. Okay, so we have negative. Hindi pala. Positive pala to. So, magma-minus lang tayo. Pareho lang din yan, no? So, negative pa rin. So, negative 6 times I1. And then, papasok niya dito. Dito na. So, we have 2. And then, yung kasama niya dito is si I3. So, we have minus 2 times I3. Then, this is equal to 0. Ayan. So, this is for our first loop, no? Sa second loop, sa B, E, F, C, B. So, we have negative 4 ohms times I2. Ito. Negative 4 ohms times I2. Dito tayo Pero notice nyo, may current tayo dyan. Tsaka yung may voltage. So, B to E muna tayo. Then E to F. So, we have 14. So, negative 14 volts. So, wala rin. So, next we have F to C. Or wala na, no? F to C. We have C to B na. Or that is your I. Or that is your this is positive. Kasi meron tayong dadaan ng positive terminal. So, papunta siya sa positive. Okay. Ito kanina negative tayo eh. Kasi palabas tayo dito sa negative terminal. Okay? Negative tayo. Dito tayo ng positive sa dito kasi sa 14 yung dapat is negative to positive. So baliktad yung terminal dito. So that's why negative 14 yung gamit natin. Pag sa resistance, labas tayo ng negative. So we use the negative. Okay? Negative 4 ohms. Dito, labas din tayo. So negative 6 ohms. Hindi. Negative 6 ohms, papasok tayo positive. Pero yung direction kasi is kabilaan. Okay? Yung direction natin dito, magkabila. Reciprocal yung direction ng I2 at I1. Therefore, we have positive 6 ohms times I1. Okay? Magkabila siya. I1. Then, minus tayo ng 10 volts. So, the same din. Kabila. Negative to positive tayo dapat. So, meaning yung direction natin dito is somewhat baliktad. Okay? So, we have negative 10 volts here. Then, obviously, this is equal to 0. Ayan. So, pwede natin i-combine yung equations natin. Okay. So, common natin. Equation 1, equation 2 natin eh. So, we can now have a simplified equation. If you multiply by 4, tingnan natin So, substitute lang pala natin. Sinubstitute natin yung equation 1 dito sa equation na to. Okay? So, therefore, we can have equation 3 natin. So basically this is negative, simplify na natin to. This is negative, ilan ba to? 24 plus 6i1 ito minus 4i2 equals to 0. Okay, so sinimplify na to. So ito yung equation 2 natin. Ito yung equation 3. Ito. Okay. So ito tsaka ito, the same lang to. Inad ko lang yung negative 14 tsaka 10. Ayan. So pwede nating isolve yung equation 1. Ito. So substitute na natin yung equation 2 natin dito. Alright, so that is 10 volts, positive 10 volts, minus 6 times negative 1, minus 2, di ba? Then yung I3. Yung I3 natin, so pwede natin siyang, kasi palabas to di ba? So we can have it by I1 plus I2 is equals to I3. Diba? So if we refer this point, I1 plus I2 is equals to I3. Tama? I1 plus I2 is equals to I3. So meaning pinasok natin yung dalawang current, lumabas siya ng isa. Ayan. So dito tayo nag-base. Okay, so clockwise pa rin yung direction natin. And in this case, yung I3 natin na to, substitute natin dito. Okay? So therefore, you have now your 10 minus 6i sub 1 minus 2 times, yung I3 natin is I sub 1 plus I sub 2. You have your I1 plus I2. Ayan. Okay? So meaning meron tayong single equation that have two unknowns na lang. Okay, then obviously this is just the same pa rin, equal to 0. Alright. Now, we can multiply each term now in our equation 3 by 4. And each term in equation 4, so kunin muna natin yung equation 4 natin. That is 10 volts minus 8i minus 2 amps, no? So, bali, inad lang natin. So, we have the 8 ohms now. Minus 2 ohms times I squared. Okay. Minultiply ta lang siya, no? Ito. Alright. So, dinistribute natin to. And then, if we simplify this equation, we have the equation 4. That is equal to 10 volts minus 8i minus 2i sub 2, which is also equal to 0. Ano talaga, distributive property talaga niya. Then, kinombine natin yung like terms. Okay? Yung negative 6i plus negative 2i. So, you have negative 8i equals to 0. So, ito yung equation 4 natin. Then, multiply by 4, no? Hindi pala natin multiply by 4. So, paano natin to ma-reduce? By elimination, no? Tama ba? Uh-huh. So, inad natin yung equation natin. That is negative. So, we have equation 4. So, multiply natin by 3. But we have negative 96 volts. So, saan nanggaling yung negative 96 volts? Okay, so kung titignan natin dito, we have 24i minus 16i sub 2 equal to 0. Pero ang tanong ko, bakit negative 96 volts to? Saan galing yung negative 96 volts? Tingnan natin. So, multiply natin each term by equation 3 by 4. Then, distribute natin. Then, each term in equation 4 by 3. So, this is specifically, okay. So, multiply natin to by 3, no? So, this is 30 minus 24i, tama? Minus 6. 6i sub 2 equals to 0. Ayan. Okay, tama ba? Ito. Yung equation 3 kasi, ito, multiply naman natin to by 4. So, multiply natin to by 4. So, magiging negative 96 to. Negative 24. So, makakancel out yung I1 natin. So, matitira would be I2. Okay? So, nakuha natin yung equation 5 by multiplying equation 3 by 4. Okay? Para ma-cancel out natin to later on. Yung, eto, yung I1. Kasi i-add natin yan eh. Okay? So, once we cancel out the I1, matitira na lang dito is eto. Negative 66 volts minus 22 ohms times I2. And from this equation, you can solve for your I2. That is negative 3 amps. And if you have your I2 now, simply back, no? You can compute for I1. I-transpose mo lang siya dito, gamitin mo lang siya dito. Okay, then you can solve for your I1. Then to solve for your I3, you can just use the basic formula, the additional. Yung I1 plus I2, which is equal to your I3. Yun na yung basic explanation dito. Okay? So first, you need to hanapin niyo yung kasi 3 equations, 3 unknowns to. Okay? You should have your 3 equations to solve for 3 unknowns. Our first equation is ito. Second equation natin, ito yung nawala. Yung nawala na yung nawala na yung I2. Then, third equation natin is yung nasolve na natin yung value ng I2. Then, transpose natin para makuha natin yung I1. Right? Okay. So, questions, clarifications before we end our discussion. Malapit na mamatay yung laptop. Are we guys clear? Are you there? May pamangkot before we end? Wala? So, I think that's it, no? So, posting your I will be posting your pre-final exam uh, today and submit it by next meeting. Okay, that is I think next Monday, next Monday. All right. So if you still have if further clarifications, just send it na lang sa messenger. Okay. I will just reply as soon as I can. Okay. So thank you for joining our class and that's it now. Bye bye. I'll just stop sharing and stop recording.